What I have here is a blank empty instance of Link Data Hub, and then I will also be using the healthcare repository by AtomGraph. So suppose the use case or the task that I have is to explore and navigate that data set without having prior knowledge of the structure of the data or the ontologies used in it, and maybe without even SPARQL skills. And the second part could be that I have to reuse some of that data, some entities in my own context, in my own data space. So that would be a more fair data related scenario. So the first thing I need to do is to create a SPARQL service. And I'll use the endpoint of the healthcare repository and just call it healthcare. So now we've registered it in the system, and we could start exploring it. If I knew SPARQL, I could start executing queries in the SPARQL editor, but this time that's not what I want to do. I want to generate automatically some entry points into that data set, and I can do that. First I need to create the root container, which is another word for collection, to those entry points. So I'll call it healthcare as well. So now in this container, what I can do is click generate containers. Yeah, I'll select healthcare here as the parent, and then I'll select healthcare, the service. So the container and the service, those are two different things. So when I click load schema, what it will do is it will query the endpoint and get a list of classes used as types in the data, right? So essentially it will load a schema from the endpoint and even rank the classes by the number of instances that they have. And now I can pick and choose from that list. Let's say I don't need the owl class, a collection for that. But when I click generate, Link Data Hub will create a new container, new collection for each of those classes that will show a list of instances of that class, right? So let's say if we go to trials, now we will get a list of all the trials in that clinical trials in that data set. So we're looking just at one page. By default, it's 20 instances, and of course we can paginate, we can order by different variables, we can change the ordering direction. So, and yeah, pagination is necessary because, as we can see, that in total we have over 60,000 instances in this container. So with some additional configuration here on the left, some customization of a SPARQL query, we could have a faceted search, which would enable us to filter by some property values, and that works in combination with what we have here on the right. I think that's the most interesting thing. It's what we call related results, but it's also known as parallax navigation or set-based navigation. So what it allows us to do is to jump from this initial set of clinical trials into a related set over an RDF property. So let's say if I choose this mentions mesh diseases property. So what happens behind the scenes that a new SPARQL query is being generated and then executed on the healthcare endpoint. And now we went from trials, we went to diseases, right? And as you can see, now the list is an instance, is a list of instances, of disease instances that are related to the trials we were looking at initially. And now, as you can see, there are only 1,400 of instances on this list. And we can continue through this related results navigation as long as there are properties in the result set. And you can see it's taking a while because we're generating a more and more complex query with each step. We're adding a new triple pattern behind the scenes. So now we went, I guess, into some sort of sets of diseases or classes of diseases. So with just 2 clicks, we went from clinical trials to a set of diseases they're associated with, and to some sort of set of disease classes, I guess, right? So now for the second part of reusing the data in my own dataspace, we can go back to trials. And let's open one specific instance. Okay, so let's say I want to reuse this data and have it in my own dataspace. So what I can do is simply click this save button here, and it will open a form that will allow me to clone the data into a local document. So I'll create a new document for that purpose. And I'll call it my trials. Okay, and now when I click the save button, we'll get the data from the healthcare repository. As you can see, it's the same data here, the same trial instance, but now it's in my own document, which is backed by a name graph in my own triple store behind Link Data Hub. So what I can do now is I can go into editing mode, right? I can start changing the data, removing, adding properties, and so on. But probably the most interesting thing is I can add new types to this trial instance. So let's say I have the SCOS ontology pre-configured and imported. So when I added the type concept from the SCOS ontology, you saw that the form was appended with the 2 new properties. And that is because we control the appearance of these data editing forms here in a data-driven fashion. So we have constructors attached to classes, like concept in this case, that say what kind of properties are the default for an instance of that class, which ontologies on their own, they don't carry that information, right? But we allow managing this. You can call it a form template in this way, right? So I'll label my trial, for example. So this trial instance will now be a SCOS concept with the label my trial as well, as you can see here. But maybe I'm not satisfied with that template for a SCOS concept. So what I can do, going back into editing mode, I can click edit constructors here. Maybe I decide that this is-top concept scheme is actually not required, is not necessary for concepts, right? So I can simply remove it from the constructor, and then when I save the changes in the constructor, before reloading the editing form, I'll show you that here we have is-top concept in scheme property, but now when I'll reload the editing form, so the new constructor will will go into effect, you can see that property is now gone, right? So without leaving the editing mode, we change the template for this form by removing a property, or we could also add new properties and change, as you can see here, we can change the types of the object, right? We can choose a class that is an expected object, for example. So this is also a pretty neat feature. I don't think it has alternatives in other semantic platforms. So, and the last thing I can do, I can copy the URI of my trial now, and if I go back to the front page, I can create or append some new content, again, just inline. So I'll add one block of HTML. So we can augment this document with new blocks of content that get appended here, right? And there are two types, resources and HTML. So I just created HTML, but now I can create a resource content and just use the URI of my trial, and it will get embedded here. Okay, so this way I can compose rich data-driven documents just from blocks of structured content, right? So I hope this illustrates how Linked Data Hub, without any customizations in this case, although it can be customized, especially the UI in different ways, how it can be used to explore and navigate a SPARQL endpoint, as well as reuse some data from that endpoint by transferring it over into our own data space and then creating some structured content with it. Okay. Thanks for your attention.